Remember the definition of acceleration? Acceleration equals change in velocity divided by the time interval. But what actually causes acceleration? The cause of acceleration is force. When a hockey puck is at rest, the net force on it, gravity and the support force, is balanced, so the puck is in equilibrium. Hit the puck, that is, apply an unbalanced force to it, and the puck experiences a change in motion. It accelerates. Apply another force by striking the puck again, and the puck's motion changes again. Remember from the previous chapter that the combination of forces acting on an object is called the net force. Acceleration depends on the net force. To increase the acceleration of an object, you have to increase the net force acting on it. An object's acceleration is directly proportional to the net force acting on it. Push on an empty shopping cart, then push equally hard on a heavily loaded shopping cart. The loaded shopping cart will accelerate much less than the empty cart. Acceleration depends on the mass being pushed. The same force applied to twice as much mass results in only half the acceleration. The acceleration is inversely proportional to the mass. Inversely means that the two values change in opposite directions. As the denominator increases, the whole quantity decreases by the same factor. Newton's second law describes the relationship between an object's mass, an object's acceleration, and the net force on the object. By using consistent units such as newtons for force, kilograms for mass, and meters per second squared for acceleration, we get the exact equation A equals F over m, where A is acceleration, F is net force, and m is mass. If the net force acting on an object doubles, the acceleration is doubled. If the mass is doubled, then the acceleration will be cut in half. If both the net force and the mass are doubled, the acceleration will remain unchanged. As mentioned in the previous chapter, friction is a force and affects motion. Friction acts on materials that are in contact with each other. It always acts in a direction to oppose motion. When two solid objects come into contact, the friction is mainly due to irregularities in the two surfaces. Rubber against concrete produces more friction than steel against steel, so concrete road dividers have replaced steel rails. The friction produced by a tire rubbing against the concrete is more effective in slowing the car than the friction produced by a steel car body sliding against a steel rail. A concrete road divider has a better design than a steel road divider for slowing an out-of-control side-swiping car. The concrete divider is wider at the bottom to ensure that the tire will make contact with the divider before the steel car body does. Both liquids and gases are called fluids because they flow. Fluid friction occurs as an object pushes aside the fluid it's moving through. The friction of liquids is appreciable, even at low speeds. Air resistance is the friction acting on something moving through air. When friction is present, an object can move with a constant velocity even when an outside force is applied to it. In such a case, the friction force just balances the applied force. The net force is zero, so there's no acceleration. A diagram showing all the forces acting on an object is called a free body diagram. The direction of the force of friction always opposes the direction of motion. Push the crate to the right and friction acts toward the left. The sack falls downward and air friction acts upward.